Tag TV and Tag Radio. Be seen and heard by both technology users and technology producers throughout the state of Georgia and around the world. Low cost, big benefits, powerhouse online branded video and audio has arrived. Tag TV, Tag Radio, there's a lot more to know. This edition of Tech Talk is brought to you by Globalspeak.com, new media consultants, corporate video and audio communications, video and audio production and distribution, live and virtual event production. Tag TV and Tag Radio is a service of Globalspeak.com, creatively delivering powerful marketing, video, and audio solutions. You've probably heard about them, maybe even have seen one. You know, the Transformer, computer-generated special effect, high animation movie blockbusters. Well, take that concept for a moment and apply it to an entire industry. This one is a wow on the Richter scale. Total transformation of an entire industry as it integrates information technology and its infrastructure into a totally new package. The promise of both cost and environmental benefits, while at the same time providing consistent service and almost science fiction-like human-computer control. It's called the Smart Grid. First, mark your calendar for October 13th as the MIT Enterprise Forum and TAG bring you a powerhouse panel of experts and visionaries to tell you all you need to know on how you and your business will benefit from the grid of tomorrow, today. But now, greetings everyone. It's Tuesday, October 5th, 2010. This is a one-of-a-kind, you're going to be blown away Tech Talk with Technology Association of Georgia President Tino Mandela. I'm your guest host, Frank Baia. We continue our exploration of the smart grid phenomenon as we go beyond basics to a view of the future you simply will not want to miss. That's right. Sit back and prepare to be totally amazed as we grid down with TAG Smart Grid Society Chairman of the Board, Anthony Maiello, General Manager, Systems Engineering, General Electric Group. Anthony joined GE as Chief Engineer for Software in 2003. Later named Technology General Manager for Network Reliability Products and Services. In 2005, he developed and executed a vision to create a world-class global software architecture, integrating energy software capabilities. By 2006, the GE Software Solutions Group was formed, and in 2007, the Systems Engineering Team was formed with Anthony as its General Manager. It's all about the smart grid in less than the time it takes you to finish that cafe latte, as we experience a rare opportunity to speak with one of the mastermind's leading advocates and visionaries, GE Energy Group General Manager Anthony Maiello. Anthony, welcome to Tech Talk.
Thank you for having me on the show, Frank.
What an exciting topic. A lot of great things going on. The convergence of technology is impacting everything everywhere, and certainly it obviously is happening in the utilities industry. All the buzz, energy internet, reducing waste, consumer energy management, impacts on outages. I even understand there's enabling electric vehicles. I know our listeners are going to be really interested in hearing more about this. We've heard a lot about the hype. Maybe from a straight-talking situation so somebody can understand, what does GE believe that the smart grid is all about?
Well, I'll tell you, Frank, this question I get a lot. And the question does require more than a couple of minutes to answer properly, but I'll see what I can do as far as summarize. Well, let me start this out by giving you a couple of scenarios and analogies that people can certainly relate to. Alexander Bell, for example, we all know he invented the telephone system over...
Now, wait a minute. Do we have enough time to go that far back?
Yeah, yeah, we do, and actually there's good reason for me bringing it up because we're going to see how archaic the grid actually is today. So Alexander Bell, you know who he is, invented the telephone system over 100 years ago. So imagine if he came back to life today and he saw the things happening around his invention, around the telephone system, and he'd be virtually lost. He wouldn't be able to recognize texting or cell phones or all the huge technical changes to his core technology. It just simply won't make sense to him, and he'd be lost. Now take Thomas Edison, who we know invented the electric grid over 100 years ago as well. If he came back to life today, well, he probably wouldn't be lost. He'd see it and say, yeah, I get it. I understand this. There's rotating machines and transformers and capacitors and such, and I expected it to get bigger and safer. I was smart enough to know that, but everything makes perfect sense is exactly what I figured it would be. And why would he say this? He'd say this because the grid has gone virtually unchanged over the last 100 years. Yes, it's gotten bigger and safer and perhaps a little smarter, but it's still technically very similar to what the original system was that was invented 100 years ago. So, you look at the grid, it served us well over the years, and that's because power has been pretty cheap over the years and such. But now there are many political, many economical drivers that companies like GE, we're looking at this, and it's causing a change in the way we're thinking. Consumers are demanding more electricity. We all have plasma TVs or very products that consume a lot more electricity than even just 10 years ago. So consumers are demanding more electricity, and they're even expecting higher reliability. So the existing grid is no longer capable of handling these kinds of loads, which hence is making the hype for the smart grid. So to make the electric grid smart, what GE believes, if you imagine taking or marrying the traditional grid that I just talked about that was invented over 100 years ago and marrying it with modern IT and telecommunications infrastructure and technology that helps us add communications of information as well as software for intelligence. So the analogy there is, if you go back to Thomas Edison, if you take what he invented and you take all the new advances of telecommunications and technologies originally developed by Alexander Bell, and then you throw in some software innovation invented by people like Bill Gates, now you've got the beginning of the smart grid. So the smart grid really becomes smart when you're, and this is what GE believes, when you can collect and manage the massive amount of data that's out there and be able to transform that data into what you would call logical information and use software, or what we term analytics, smart software. You use that on the information in order to enable things like efficiency, reliability, renewable integration. We'll talk more about that later, I'm sure, and also engaging the consumer, which is a big part of the smart grid. So it's a two-way street. It's not just one-way push power. It's a two-way street. How do we engage the consumer in order to make the grid smarter? And a critical piece to this is the operators of the smart grid, the ones that work for the utilities. They're going to need a new generation of advanced visualization tools that'll basically help them determine the state of the grid with just a glance at their screens. They don't have these complicated lights and bells and whistles that they have to figure out what's going on. This will be a quick glance at the screen. They'll know what's going on. So in summary, GE looks at the smart grid as a set of end-to-end solutions. It's no longer pieces of products. It's actual end-to-end solutions, which result in what we label an interoperable system of systems. So it's more than one system that's providing advanced solutions to some really major utility problems that are out there, and it's doing it in real time in a manner in which operators can easily understand and have the confidence that the solutions will deliver on the reliability, on the efficiency, on the renewables, and the integration, and actually be able to coordinate consumer engagement.
Now, I'm probably oversimplifying it because, again, you're into it, you're an engineer, you're close to it, and been working on it, obviously, for an extended period of time. Hearing what you just described, would I be wrong in saying that we're talking about integrating information technologies with the current electrical infrastructure, but in a way that somewhat in the future might represent my iPhone applications or something like that, like a cloud connection to the Internet, where I would be able to, not only the actual manufacturers and distributors of power, but consumers would be able to interface with the content through information technologies?
Yeah, that's exactly the right way to think about it. It is could be considered a cloud, perhaps not in the definition that how we define the Internet clouds of today, but more of a private cloud. And that's exactly right. The consumers will be interacting with information out on the grid, as well as the utilities interacting the other way around, down to the appliances in the home.
Now, obviously, we've seen such any more change is so rapid. It's almost a cliche to say it. I say so 20 minutes ago, because if you don't check, something has changed so rapidly. It doesn't happen dynamically anymore. It has phantasmagoric. I mean, yesterday we didn't have iPhones. Today we can't live without them. This sounds like it's a huge, huge undertaking. It's a system of systems. I get that. but can you explain briefly what it's going to require to deploy this thing?
Yeah, you bring up a great point. I'll take a kind of a human resources and a technology approach here. So as you've heard me say earlier to your previous question, one of your previous questions, is the smart grid is very complex, and as you stated, it's a system of systems. There's components and a bunch of subsystems that all need to come together. Now, this concept, system of systems, this complexity, is relatively foreign to the electric utility industry. See, traditionally, utilities have operated their subsystems in what's called a very independent islanded mode. So these systems never really communicated with each other. Now we're requiring them to communicate. So, for example, in the past, utilities have operated their transmission side of things and the distribution side of things completely independent of each other. So if we're going to achieve the industry's expectations now of the smart grid, the way I just explained it, every subsystem has to be integrated in a single smart grid system of systems. This is going to require huge, dramatic changes to the kinds of people and the kinds of technology that we need. So first, the industry. The industry is going to have to take a systems engineering approach to building the smart grid. Now, again, this is relatively new discipline. It'll take a major challenge to find some good people that are the right system, that have the right systems engineering skills. Now, luckily for us, right here in Georgia, we've got the Georgia Tech, we've got Southern Polytech. They have very good system engineering disciplines and schools within their academics. Mm-hmm. They're producing some really great systems engineers that GE's hiring, and we're working very closely. We've partnership with Georgia Tech, for example, on a recent smart grid, a set of smart grid activities, and we're starting to produce some real systems thinking right out of school. And secondly, the industry has to come together to agree on they're talking about tools now, a full suite of technical standards and tools that help us define interoperability for the smart grid. So you take organizations like the IEC and the NIST organization, who are responsible for standards for the smart grid. They've taken a lead on this, and GE has actually taken a leadership role as well in both of these conversations at the IEC and NIST level. So both of those organizations are pushing hard to accelerate standards development. This drives interoperability of these components. That's the standards and the process. So I'm very optimistic that we're going to get this done and get it done properly, because the industry has some very talented people that are actually working on this. So I've previously spoken about complexity of the grid. Now, the smart grid can't be implemented with traditional engineering tools and methods either. So GE is investing in, and it's also training its engineers on a wide range of new system engineering tools and processes, which will help ease the actual complexity and help us streamline this process. So new tools, I'll give you examples, Enterprise Architect, Rational, IBM's Rational, database querying tools. They've all helped us aid in the productivity that we need, and also the accuracy of the system design. In fact, IEC and NIST, I said earlier, they've approached GE to help them use the same kinds of tools and processes in the design of these new interoperable standards. So in summary, we have to work very closely with universities. We have to work very closely with partners, various companies that build various parts and subsystems that are going to be required for the smart grid to be successful. And also not only to develop the talent in the universities, but also to develop these next generation of system engineering tools as well.
Absolutely. I guess in a word, transformational. You couldn't say disruptive because it's an evolution, but what we're talking about here is cultural impacts in terms of industry, cultural impacts in terms of the consumer, but huge economic development opportunities and great innovation opportunities. I would imagine, my mind's going crazy, but I'm thinking like the space shuttle or something where, you look at the simulation of trying to do it, but in doing it, you identify weaknesses and opportunities that, from an entrepreneurial standpoint, create new technologies. I'm going to assume that there's got to be a broad opportunity for all kinds of new business and new innovations to accelerate the situation along. Let's talk a little bit about benefits as it relates to the average consumer. Maybe get down to the nitty-gritty in terms of both electric utilities and the average consumer of electricity. What clearly are going to be the benefits of this smart grid, and maybe again, how long will we see it in the near future? Is it how far out is it going to be before we really start seeing an impact from it?
Well, yeah.
Like for example, I guess bottom line, will I see lower electric prices at any point because of it?
Yeah. So first of all, the smart grid is not a thing. It as you said, it's evolution. It will take years to fully deploy. But let's start with the utility, then we can go down to the consumer and address that electricity prices question. So as far as the utilities are concerned, they're really focused on 5 major areas to derive benefit. And let me quickly take one at a time. The first I mentioned earlier, it's grid efficiency. So if you look at electricity losses, and that's losses from the point that power is generated and leaves the power plant to when it gets into your home or office, there's sometimes in excess of 10% loss. So 10% of the electricity has been lost. In some countries, it actually is about 20%. But let's stick to the U.S., it's about 8 to 10%. This translates into billions of dollars lost in the U.S. alone for utilities. So there are plenty of opportunities for improvement here. GE has developed a number of solutions, and we continue to develop more as the smart grid gets deployed. And what they'll do is they'll help the utilities push these losses as low as possible. So that helps the utility in many ways, not just financially, but even efficiency-wise as far as delivering to the customer. So the second benefit is network reliability, and this is big for utilities. As I said earlier, with a huge number of electronic devices in the home today, customers are not nearly as tolerant either of power outages as they once were in the past when the grid was kind of new. And also there's a lot of people that are working out of their homes, and their livelihoods depend on power staying on. So GE has deployed many things, many solutions as well, many different systems, and they continue to deploy as well. That's shown to substantially improve the reliability to very high levels. Major benefits not only to the consumer but also to the utility because they financially save every time they can keep the lights on versus have a blackout. Thirdly, electric utilities, they want to get a lot more out of their existing assets without impacting network reliability. So they want transformers to last longer, capacitors and things like that. And again, GE has a broad range of advanced sensor technologies and monitoring capabilities and things like that in order to help them. Another area on demand, as I said earlier, demand for electricity continues to rise. Utilities now have to control and manage consumer demand. So this is the first time they ever had to deal with this. Usually they would send one-way electricity, whether you need it or not. It'll go to your home or office, and basically that's it. But now utilities have to know what's going on at the consumer because they have to do what's called manage the peak. Utilities can no longer simply just add power generation, for example, or new transmission lines to increase capacity, because siting for new lines and power plants could take up to 10 years and virtually impossible these days. So utilities have to work with their customers to control the demand without impacting their lifestyles. So there's a number of new smart home technologies and smart grid technologies to help the consumers do that.
Some kind of storage devices or something for off-peak periods?
Exactly. And someday you might actually have a battery in the basement of your home that's used during peak time, or you may even be plugging your electric vehicle and that's actually used to power your home for part of the day. So there's lots of things going on there, and I wanted to address the second part of your question as well. But before I do, lastly, the utilities are expecting big benefits from what's called renewable energy sources, such as wind and solar. Now, the government has set some very aggressive targets for the introduction of renewables in order to reduce greenhouse gas emissions and pollution and such. The problem with renewables, they're intermittent. So the sun doesn't always shine, the wind doesn't always blow, and so forth. So there are a number of new energy storage systems that you just brought up that can control these kinds of problems, and they're currently being developed. Do we have full solutions out there yet? No, but it certainly gives lots of opportunity to entrepreneurs and other vendors as well that are in this field, and it'll help us greatly mitigate the impact of these intermittencies once we can figure out how to deal with that. So to deal with the second part of your question about energy prices going down, this is a really tough one and argued over and over again, not only at the political level but even at the economics level. The way I look at this is, fuel prices are going to continue to rise. So, logically, I don't see the cost of electricity coming down. However, I strongly believe that the benefits of the smart grid will offset some of the impacts that we're going to see because of fuel costs, which are basically allowing moderate increases in electricity prices if the smart grid is successful at what it's trying to do.
So in a way, the real angle from an outsider looking in is to make sure that you deal with electricity or utilities as efficient as you possibly can, and then also to make sure that you've got 100% access all the time. If those two things are done, then in a way it's a value, not necessarily a cost saving, but truly a value, because you'll be able to have the consistent flow and you'll be able to efficiently manage it. Like, for example, now the cost may be cheaper, but because we're not efficient with the way we're managing it, we actually end up spending more money in the long run. Oversimplified, I'm sure, but something basically like that.
That's right.
A good opportunity now would be to mention the fact that the MIT Enterprise Forum in Atlanta next week, I think October the 13th, is going to be conducting a forum, a summit, dealing with this subject, and it's if anyone is interested, any of our TAG members or any listeners, in finding out how their business can benefit from smart grid technology, or even better than that, maybe how new products or services or business models can help them grow their profits or even shrink organizational carbon footprints, you're going to want to attend this event, and it's still open for registration. But I think all you need to really do is just go to mitforumatlanta.org or go to tagonline.org, and there'll be information there on how you can register. Anthony, some quick things. We're running out of time. How about looking forward now? I always love this because looking forward when you're talking about the ultimate matrix of layers and tentacles and how things hybrid and all of the changes and things that happen. But do you see any major problems facing the utilities or consumers on this thing, on getting to solve problems by using the smart grid?
Yeah. Let me talk about renewable energy sources again. Again, major impact on the way electric utilities, renewable energy sources will simply have a major impact on the way electric utilities currently operate their systems and how they effectively run their business. So as renewables become more prevalent, utilities will they could start to lose revenue from their traditional generation business. I mean, think about that.
Yeah.
Look at Walmart. About a year ago, has announced that they've already announced a major solar installation program on their store rooftops. What impacts will this have, if you think about it, on the purchase of power from their local utilities? That needs to be evaluated. But, however, for many utilities, it's not just their local utility that one Walmart is in. Walmart's all over. So for many utilities, Walmart is a major customer, so these utilities are obviously concerned. So the analogy is the impact that network PCs had on IBM's mainframe business.
Sure.
If you think about the whole computer industry moving to PCs from large centralized computers, it's not that different now. How would that be translated to power plants compared to renewable energy? So utilities will have to make a decision sooner or later on how to run their business. The question has to be: are they going to let other companies purchase and install renewable energy sources, and they become like a wires company and a supplier of reserve energy to handle renewables intermittency, or will utilities become suppliers of renewable energy sources like they are for regular power generation right now, which is basically displacing their own traditional generation. So smart grid technology is going to play a big role in this kind of transition, and I'm personally looking forward to being a part of it. But utilities have these critical decisions to make there. You take a look at another major concern to electric utilities is what the impact of electric vehicles may have on distribution networks. the changing load the charging load of an electric vehicle is equivalent to what I like to use about a quarter of the load of a whole home. So if everyone in your neighborhood buys an electric car, that would be equivalent to adding one new home for every 4 houses that exist today. This is a large increase in load. Today's distribution networks, as I said earlier, they were not originally designed for this kind of load. So smart grid needs to really happen in order to allow this kind of activity to happen.
Absolutely amazing. Again, I say to anybody that's interested, you really need to show up next week, because you learn more about it now and get more knowledge as it evolves. You're going to be able to benefit from it even more. So one last wrap-up quick question, Anthony, and that is, how about emerging technologies? I mean, I mentioned earlier about it seems like anytime there's game changers, especially a major one like we're talking about, certainly there's going to be some new emerging technologies that I guess would revolutionize what we understand to be the utility system, but certainly even the smart grid as it evolves.
Yeah, this is another question that could take days to answer, and I'll try to do so in 30 seconds here. As far as GE is concerned, we have a number of research projects going on in our 4 research centers throughout the world, and we've got lots of work going on with different universities and certainly considered real game-changing smart grid technologies. Now, I'm not going to give you the detail here for obvious reasons, but I can tell you in general where at least GE is doing a lot of research here. First, I talked a lot about renewable energy. However, there are other, both solar and wind energy if you take a look at renewables, they really need tax credits today in order to compete economically compared to traditional energy sources. So if you take an entrepreneurial look at this and say, let's say that never happened, and you need to develop some new lower-cost solar panel technologies such as thin film or nanowire multifunction cells and things like that, or new wind blade technologies in order to make these renewables more competitive. So if the tax credits don't happen, there'll still be technologies that compete with the existing traditional energy sources. Second technology area, if you look at coal, today coal is our cheapest and simply our most abundant source of fuel in the United States for generating electricity. However, coal produces greenhouse gases. That's very bad. So with new government pushing regulation on restrictions here around greenhouse gases and coal-fired plants, they were asking for coal-fired plants to be shut down. So companies like GE and others, we're researching a number of carbon type of filtering technologies which will allow coal-fired plants existing today to meet and in most cases exceed current and future greenhouse gas emission standards, and that's a huge opportunity as well for various companies to get into as well. Third, the smart grid will involve a lot of data. I said it earlier, it's a massive amount of data that we're going to transform to information and visualization for the operator. We're already approaching, I don't know how many software people are out there, but petabytes of information. This is just an incredible amount of data. So the smart grid is going to require analysis of this kind of volume of data, and it needs to do it in real time because it's managing the flow of electricity. So we're currently researching, and others as well, new database technologies, advanced computer systems, and things like that to ensure that the smart grid is ready and it can analyze that kind of volume of data. And very quickly, going through others, battery technology, they're key components of electric vehicles. Today's battery technologies are just not economical enough, so we need some research there. Just to list a few others is modeling and simulation for systems. There's advanced visualization techniques that I said earlier that will give operators greater situational awareness. There's 3D modeling that will allow for more advanced diagnostics and prognostics of grid assets. And then for a lot of people, there's Web 2.0 and Web 3.0 technologies. You know, these technologies will impact consumer behavior, how they use electricity, and things like this. Now, that's just a short list, but there's lots more.
Well, there is lots more, and the great part of it is that the Tech Talk will go on, and as you guys progress, we're certainly going to invite you back. It's an incredibly deep subject, a lot of opportunities, a lot of exciting information, but unfortunately, we've just run out of time, but hopefully we'll invite you back for another Tech Talk. Anthony, thank you so much for taking your time today out of your busy schedule to share all this information with us.
Well, Frank, thank you very much, and I really believe in what you guys are doing, and I look forward to the MIT conference as well.